right, let's get right into it. We're going to pull back the curtain on one of the most common, yet seriously overlooked components in the entire world of electronics. It's this tiny little piece of tech that, makes almost everything you use possible. I mean, just think about it for a second. Your phone, your laptop, those earbuds you're probably wearing right now, they're all these incredible pieces of engineering. We tap on the screens, we click the buttons, but deep down inside, there's a whole city of tiny parts all working together. And in that city, there's one component that's, more fundamental than pretty much any other. It's in practically every circuit board ever made, just quietly doing its super important job. So, what is this unsung hero? Say hello to the resistor. Yeah, I know, it doesn't look like much, just a tiny little thing with some colored stripes on it, but its job is one of the most critical in all of electronics. It's basically the traffic cop, the gatekeeper, the bouncer for electricity. So to really get a feel for its power, we gotta first understand what it actually does. Well, the name kind of gives it away, right? A resistor's one and only job is to resist the flow of electricity. It's basically an intentional bottleneck designed to manage just how much juice gets from point A to point B, which is crucial for protecting the more sensitive parts down the line. But how does it do that? I mean, it's not just random. There's this beautiful, simple law of physics that dictates exactly how this all works, and believe it or not, it's actually pretty easy to grasp. And that, my friends, brings us to the core principle behind every single resistor out there, a little something called Ohm's law. Now, the absolute best way to get your head around this stuff is to forget about electrons and wires for just a second. Instead, I want you to just picture water flowing through a regular old pipe. This one simple analogy is going to make everything click, I promise. So first up, we've got voltage. In our water pipe world, this is just the water pressure. It's the force, the push that gets the water, or the electricity, moving in the first place. More voltage, that just means more push. Then you've got current. This is the actual amount of water that's flowing through that pipe. It's the volume of electricity that's on the move. So more current means more electricity is actually flowing. Simple enough. And here it is, the star of our show, resistance. In our pipe, this is like a narrow section, a little squeeze that, you guessed it, resists the water. It doesn't totally stop the flow, but it definitely controls how much can squeeze through. The tighter the squeeze, the higher the resistance. And this is where it all comes together so beautifully. Voltage equals current times resistance. V equals I times R. This incredibly simple, totally elegant formula is basically the rulebook for countless electronic circuits. It means if you know any two of those things, you can always figure out the third. It's the key to taking control. Okay, so we know the rule it follows, but what is a resistor actually made of? What's inside that tiny little package? Let's pop the hood and take a look. So let's break it down. A standard resistor is a really simple device, and its construction is the whole reason it can do its job so perfectly time after time. So at its heart, you've got the resistive material, something like carbon film. This is the part that actually does the work, the part that creates the squeeze, and engineers can tweak its exact makeup to get precisely the amount of resistance they need. Then you have the metal leads. Think of them as the on-ramps and off-ramps for the electricity. And the whole thing is wrapped in a tough outer shell to protect it from the elements. Simple, but so effective. Now, here's where it gets really interesting. When a resistor does its job, when it slows down that flow of electricity, that action has consequences. But in this case, there are actually two really useful side effects. So what happens is that all that resisting creates two main results. It generates some heat, and it causes the voltage to drop. And what's so cool is that engineers have figured out how to use both of these things to their advantage. Okay, check this out. On the left, you see heat. That electrical energy has to go somewhere, right? So it gets converted into heat. Sometimes that's just a thing you have to manage, but other times that's the whole point. Think about a toaster or an electric heater. They're basically just big resistors designed to get really hot on purpose. Then on the right, you've got what's called a voltage drop. By resisting the current, the resistor lowers the electrical pressure. And this is absolutely vital for delicate things like a microchip or an LED that need just the right lower voltage to work without, blowing up. The resistor makes sure every part gets exactly the power it needs. All right, let's zoom out a bit and look at the big picture. We've seen what a resistor is and how it works, but what makes this super simple component so revolutionary? Well, it's because that simple principle can be adapted in a ton of different ways. You have your standard fixed resistors that have just one value, but you also have variable ones like the volume knob on an old stereo that lets you change the resistance. And then you have these really clever specialized ones that can react to things like light or temperature, acting like tiny little sensors. And that, right there, is the real magic. The power of the resistor is that it does one simple thing, but it does that one thing perfectly. And that simplicity makes it incredibly reliable, super cheap to make, and just unbelievably versatile. It's the ultimate building block for electrical control. It's a pretty wild journey when you think about it, isn't it? You start with a basic law of physics, Ohm's law, and that one idea leads directly to the incredibly complex gadgets that power our entire modern world. And it all comes down to being able to precisely control the flow of electricity. You know, this quote just nails it. It might be a tiny engineered component, but it is absolutely vital. Seriously, without the humble resistor, the kind of precise electrical control we need for our digital age, it just wouldn't exist. So the next time you pick up your phone, just take a second to remember the billions of tiny, unsung heroes inside, all quietly doing their job. It makes you wonder, right? What other simple components are hiding in plain sight, just making our world work? So keep asking those questions and never, ever stop being curious.